Hi folks, welcome to the lesson. We're finding the volume of a prism today. If you don't know what a prism is, don't worry, you soon will. Let's crack on and get the job done. A prism then has a constant cross-sectional area. What does that mean? Well, constant means it doesn't change. And if we look at the shape on the left-hand side, that triangle there runs from front all the way to the back. It's a constant cross-sectional area running through the prism. Similarly, for the cylinder, that circle there, the base, is a constant cross-sectional area running from the base up to the top of the cylinder. Once we know what a cross-sectional area means, this makes finding the volume of a prism relatively straightforward, because the volume is simply the size of that cross-sectional area multiplied by the length along which it runs. So for the shape, the triangular face prism on the left-hand side, the volume would be that cross-sectional area A, that's the area of the triangle, that area multiplied by the length along which it runs, which will be marked in as D on the diagram. So the volume of that triangular face prism would be A times D. For the cylinder, the cross-sectional area would be the area of the circle of the base, and therefore the volume of the cylinder would be the area of that circle multiplied by h, which is the height through which that circle runs. So in order to find the volume of this triangular face prism, we need the cross-sectional area first. That's the area flashing in front of you. It's a triangle, a right angle triangle, so the area is half the base times height, so that's 12 squared centimeters. And we want the distance along which that runs, which is 14 centimeters, so we multiply the area 12 squared centimeters by the 14 centimeters along which it runs, and that comes to 168 cubic centimeters. In the second example, as we previously discussed, the cross-sectional area we require is the area of the circle, which is the base of the cylinder. And there it is flashing for us. I hope you remember that the area of a circle is pi times r squared, where r is a radius, which is 3 centimeters in this case. Therefore, the volume is the cross-sectional area times 12, which is the length along which that cross-section runs. And that's 108 pi. We can tap that in our calculators, and then we're rounding off to 3 significant figures. And in our final example, we've got a prism which has an L shape for a cross-section. We need the area of the cross-section, so we take that shape and separate it into 2 rectangles, which I've labelled A and B. We just need to be careful with the lengths here. On the original diagram, that length is 8 centimeters, and this length here is 2 centimeters, which means this length, the side of A, must be 6 centimeters. And then for B, we've got 5 centimeters for its width, and that height there is 2 centimeters because it's the same as the 2 centimeters there. So we're good now to find the area of A, which is 3 centimeters times 6 centimeters, 18 squared centimeters. B is 2 times 5, so that's 10 squared centimeters, and altogether CSA stands for cross-sectional area, is 28 squared centimeters. The length along which that cross-section runs is 10 centimeters, so we multiply that by 10, giving us a final answer of 280 cubic centimeters. And let's put all that together in a recap. A prism has a constant area running through it. Here, the triangular face prism has a constant area running from front to back. That area is called the cross-sectional area, and the volume of a prism is that cross-sectional area multiplied by the length along which it runs. So in this example, it would be the area pi r squared times by the length along which it runs, which is h as marked in on the diagram. So the volume of that cylinder would be pi r squared times h. Pi r squared, the cross-sectional area, h, the length along which it runs. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.